All right, so we've been working on these trig ratios and how to find side lengths and angle measures. Now we want to try to give those processes some meaning, right? Put them in a situation where it actually helps us find some measurements, some heights, some angles that would be helpful in the world of, say, surveying or construction or whatever. So some applications of these guys. Applications of our trig ratios, and bottom line, this means story problems, right? Take a look at some story problems, and what will be true with these story problems is what would be true for any type of story problem in any class, and that is making sure that we get a good representation of what's going on, a good picture, right? First things first, one of the things that we're going to want to remind ourselves on is what we mean by an angle of elevation or an angle of depression. That's going to drive a lot of which trig ratio we want to use, which trig function we want to use. Angle of elevation. Elevate means to go up, right? So an angle of elevation is the angle at which I have to tilt my head up to see something. So if this right here is your original straight ahead look, horizontal line of sight, then this is the angle of elevation. It's how far I have to tilt my head up to maybe see the top of this tree. Okay, so that's your angle of, that's what we mean by an angle of elevation. Usually somewhere on the ground, but definitely below some point that we're trying to see, to look up. Versus an angle of depression. The angle of depression would be sort of the opposite. It's as if you're standing at the top of something and then you need to look down to see something on the ground or below you. That's the angle of depression. To depress something means to push it down. So your angle of depression here would be, again, if I'm looking straight ahead at on a horizontal line of sight, it's the angle I would have to make to look down at something. So that would be your angle of depression. Now, the difference between the angle of elevation and angle of depression is basically your point of view. Angle of elevation, you're below something looking up. Angle of depression is you're above something looking down. The other difference is, when we're drawing our picture, we're going to want a right triangle to represent what's going on. That way we can use our sine, cosine, tangent stuff. Well, if you notice, the angle of elevation right here is inside of a right triangle. It is an angle that we are able to go ahead and set up our trig ratios with. The angle of depression, which is right here, is not inside of a right triangle. So we can't use our trig ratios from that particular angle. So what we do instead is we bring back some geometry where we understand that the ground and our horizontal line of sight are parallel to each other, and that this segment could be a transversal, so that we're now looking at two parallel lines in a transversal, that Z that we traced in geometry, and a Z gives us alternate interior angles. And how that helps us is that alternate interior angles are always congruent when the lines that are creating them are parallel. So that means that whatever the angle of depression is from this top point, it has to be the exact same as the angle of elevation from this bottom point. So that's a way we can use, that's a method we can use to get our angle of depression into a right triangle so that we can use our trig ratios. Okay, and we'll see some examples of this along the way. Okay, first problem, and again, you understand that about angles of elevation and depression, then really it's just a matter of getting good pictures to represent what we're doing. So this says the angle of elevation from a point on the ground, 15.5 meters from the base of a tree to the top of the tree is 60.4 degrees. Find the height of the tree. Okay, find the height of the tree. That's my variable. So here's our tree. And the more detail you add to your picture, the easier, the better visual you're going to get, the easier it's going to be to see what you're supposed to be doing. So find the height of the tree. That's going to be our variable x, right? Now, the angle of elevation from a point on the ground, so over here, a point on the ground 15.5 meters from the base of the tree. So that means that from here to here is 15.5 meters. And so the angle of elevation from that point to the top of the tree is 60.4 degrees. So now we've created, right? So we had this horizontal line of sight right here, and then we had to look up 60.4 degrees to see the top of the tree. So there's what your picture should look like. And that's just from a point on the ground. It started on the ground. So from here, hopefully we can see we're getting into our right triangles and just solving our right triangles. Well, we have this angle. We want to find the opposite, and we have the adjacent. That means I need to use the tangent trig ratio. Tangent needs an angle, so 60.4 goes with tangent, and that's got to be opposite over adjacent, and so that's your equation. And if x is up high, that means we want to multiply 15.5 times tangent of 60.4. Okay, and if you were to type that into your calculator, you should get a height for that tree of 27.3 meters. Okay? Now, we've got some story problems in here, and we'll go through them, but also understand that every situation's a little different. And so it's really going to depend on you drawing a good picture to represent what it is you're wanting to do. Okay? So, next one. Stop the video. Try to draw your picture. If you don't want to solve it, that's fine. But try to draw the picture. I'll show you the picture that I come up with, and then we'll walk through solving it. Okay, so it says find the angle of depression from the top of a 97-foot building. So I got a 97-foot building here. And we want to find the angle of depression from the top. So it's as if someone is looking straight out and then has to look down at the base of another building. So there might be another building over here. And we want to find this angle of depression. Now, the building, the red building, is 42 feet away, so there you go. And there you've got your right triangle, right? Now, angle of depression. That angle is not inside of a triangle, so we have to move it and understand that the angle of elevation from the top of that building is the angle of depression from the top of that building is the same as the angle of elevation from the other building on the ground. So that's the angle that we want to use, this one right here. Knowing that our opposite is 97 and our adjacent is 42, we don't know the angle means we have to use inverse, so inverse tangent, and it's got to be 97 over 42. Right? And so you type that in, and you should get an angle of depression of about 66.6 degrees. Okay? All right. Next one. Now we're going to start adding some wrinkles into these and seeing if you can figure out what to do with the additional information. So, again, draw the picture, stop the video, draw the picture, and then start it back up. And I'll explain the picture that I got. Okay, so does your picture look something like this? So you got your red tower there, your purple surveyor's instrument, that's 4.75 feet off the ground. Now the surveyor instrument is 130 feet from the tower, and the tower is 86 feet tall. Okay? Now, it's important again, so what we want to find is the angle of elevation from the instrument to the top of the tower, right? So the instrument is right here. It's again important to draw in that horizontal, the original horizontal line of sight, which is what this guy is, right? And that from there, the instrument would have to look up to see the top of that tower, and that's the angle of elevation that we want to find. Okay? Now, if you've done that, then you have to understand that we are going to try to come up with this angle using this right triangle right here, which means using this side length, okay? That is not all 86 feet. It's 86 feet less the 4.75 feet that the instrument is sitting off the ground. So in actuality, we're going to use 81.25 feet. And then this distance is still 130 feet. The instrument is still 130 feet away. It doesn't matter if it's the top of the tower, the bottom of the tower, or the middle of the tower. So that's where we're going to come up with finding the angle by taking the inverse tangent of 81.25 over 130. And when you do that, you're going to get an angle of elevation of about 32.0 degrees. Okay, so you had to account for that 4.75 feet. That's the wrinkle I was talking about. Okay, next one. Again, another wrinkle here, so let's see if you can't figure out what to do with this. Stop the video, draw your picture, and then I'll show you mine, and we'll walk through how to solve it. Okay, does your picture look something like this? Right? So the wrinkle added in here is that the cabin itself is 2,000 feet off the ground as well. Right? So if we're going to do an angle of depression from the top of the mountain to the cabin, then we have to understand that when we draw on that angle of depression, we draw on the distance from the cabin to the mountain right here. Then we are going to create this right triangle, but this side of the right triangle is not the whole height of the mountain, right? It's only a part of it. We need that plus the 2,000 feet that were already off the ground if we're at the cabin. So, again, angle of depression not in a triangle that we can, so we can use it. So I got to move this guy down here, make this 26 degrees, and use that to find the missing piece in our triangle, which is only part of the height of the mountain. So again, we're going to use tangent. So we're going to use tangent of 26 equals x over 14,000. If x is up high, we multiply. So 14,000 times tangent 26 gives us 6,828 feet, 28.26 feet. But again, that's only to right here. And so we've got to add 2,000 to it to find the entire height of that mountain. So the entire height of that mountain ends up being 8,828.26 feet. Okay, so a little bit different wrinkle where you had to add in some distance there. All right? All right, so a couple more, and then you can start working on your homework. So here's an example of where I used some trigonometry, and I really did do this. So I was trying to make a ramp for my pet bunny. We have a pet bunny, her name is Pumpkin. We have a staircase, a little portable staircase that is carpeted, but it just drops off the back. And so we wanted to create a ramp so that she can climb up the stairs and go down the ramp, or go up the ramp and climb down the stairs, so she can play on it. The back of the staircase is 24 inches tall, and I only want the angle of elevation to be 35 degrees. I don't want that ramp to be so steep that she can't get up and down it, right? So the question is, how far from the base of the staircase does the ramp need to be? Well, good picture, right? So again, it's only helpful if you try it. So stop the video, draw a picture, start it back up, and we'll go from there. Does your picture look like that? Okay? Ramp's angle of elevation, or the ramp's angle, is 35 degrees, so your 35 needs to go there. The staircase is 24 inches tall, and I want to know how far out is this ramp going to stick, right? So then I can go tangent of 35 equals 24 over x. And since x is down low, we're going to switch these and then divide. And so if you do that, you're going to get a length of 34.3 inches. So the ramp is going to stick out about 3 feet, which is a little bit more than what I wanted it to stick out. So I did have to adjust the angle, making it a little bit steeper, but 35 degrees isn't that bad, and about 40 degrees is about okay. So I did have to kind of adjust my measurements a little bit, and I'm in the process of making that ramp now. Okay, anyway, thought it'd be kind of fun to show you where I actually just used some trig within the last couple of weeks. All right, last one. Read the problem, draw the picture, stop the video, solve it, pull it back up. I'll show you what I did, and hopefully you'll be ready to rock and roll on the homework. Okay, so the building ended up being 60 feet tall. So 10-foot tree, 17.3, meters, 60 meters tall, not feet. Sorry, I should have paid attention to my units. But anyway, so shadow was 17.3 meters long, so that goes there. And we want to find the angle of elevation for the sun, which is the tip of the shadow to the top of the tree. And so inverse tangent there gives us 30 degrees. Now, at the same time of day, as long as the building is in the same vicinity of the tree, then the angle should be hitting the angle the sun is hitting the tree should be the same as the angle that the sun is hitting the building. So we can take that angle over into our building situation where we want to find the height of the building, and its shadow is 103.8 meters long. Just use that 30.0 degrees. You're going to want to use the entire decimal in your calculation there. So carry that angle measure over, and then we're just going to do tangent of that angle measure equals x over 103.8. Since x is up high, we're going to multiply. Okay, so hopefully all that makes sense. If you're still a little unsure about what you're doing, do try some of the homework problems, but then come in and see me, and we'll figure it out.